Okay, let's finish up on this, and let me see if I can refocus this. I'm not doing a very good job of that today. Let's talk about gaming. All right. Just like the lottery, a casino is not going to play a game that they don't have, that they are not going to expect to win over the long run. Yes, you're going to have somebody come in and, break the bank on a particular thing, but in the long run, what are they going what how are they going to make projections? What do they expect to win from a particular game? So, this is what's called the house edge. The amount that a casino can expect to earn per $1 bet is called the house edge. Okay, so how do they calculate that? Well, again, you can't look at individual things. You have to look at the law of large numbers, what the expectation is, look at the probabilities, and what the value of that event is. Okay. All right, so a roulette wheel that is shown here, and it's really hard to read, has 38 numbers. 18 are black, 18 are red, and then 0 and 00 are green. If a player bets $1 on red and the wheel lands on red, they win $1. If they bet $1, on red and the wheel lands on black or green, the player loses $1. So what is the house edge for a dollar bet on red? Okay, so note, we are taking the perspective of the casino. That means if the player loses, that's money to the casino. If the player wins, that's a negative, that's a loss. Okay, so the value of not red. So let's see if we can find out what not red is. Okay, if a player bets $1 on red and the wheel lands on black or green, the player loses $1. Okay, if the player loses $1, that means the casino wins $1, because we're looking at it from the perspective of the casino. Okay, so the value to the casino, since they're winning, is $1. Okay, so now we have to find the probability of not red. Okay, well, let's see if we can figure out that probability. We know there are 38 numbers, so it's something out of 38. Okay, well, let's see how many are not red. Okay, there are 18 black, and 0 and 00 are green, which means there are 20 opportunities out of the 38 for it to be not red. Okay. Well, what's the other possible event? Either it's going to be not red, or it's going to be the value of red to the casino. Okay. Well, red to the casino is a loss. That means they are going to lose that dollar. If a player bets 1 on red and the wheel lands on red, the player wins $1. That means the casino loses $1. Okay, so let's find the probability of that. Well, we found before that there were 38 possible outcomes, and that 18 are red. So the probability of a red is 18 out of 38. Okay, so the house edge. Let's see what we can do with this. All right, well, we're going to start out with event 1, which is the revenue. Remember, okay, the value of that is $1, and the probability is 20 out of 38. Okay. Event 2 is the loss, or you could call it the cost. The value of that is -1, and the probability of red is 18 out of 38. Okay. So when you multiply this all out, what you end up with is, and I would do it just like this. I wouldn't convert them to decimals. I'd just do it in my calculator just like that. If you want to convert it to decimals, that's absolutely fine. Okay. And I'm going to write my answer as dollars and cents. So this is 0.05. Okay. What this means is for every dollar bet at roulette, I think I put too many L's in there, the casino expects to earn 5 cents. Now that's over the long run. Okay, so that means if a bazillion people come in there and each of them put a dollar bet, they expect to earn 5 cents for every dollar that was bet on the roulette table. Okay, an insurance company sells a policy for $400. Based on past data, an average of 1 in 100 policyholders will file a $10,000 claim, and 1 in 200 policies will file a $25,000 claim. Find the expected value to the company. Okay. Okay, so let's see. We've got 3 events here. The first event is selling the policy. So event 1 sell the policy. Okay. Then we have an event where 1 in 100 policyholders will file a $10,000 claim. So that's the second event. The $10,000 claim. And then finally we have a third event. 1 in 200 policyholders will file a $25,000 claim. So event 3 is a $25,000 claim. Okay. Now, just like before, we're going to have to find the value and the probability. So for all of these, we're going to do value times the probability. Okay. The value times the probability of that event. The value times the probability. Okay. And we're going to add these all together. Okay. And we're looking at to the company. So the expected value, they sell the policy. Well, the value of that policy is $400, and they've sold so the probability is 1. Okay, so that is income. This is going to be revenue. Okay, if they have to pay out a claim, this is going to be a cost. So the value is to the company is going to be negative 10,000. And the probability of that is 1 in 100. And event 3 is a claim, so that is going to be a cost to the company. So the value is going to be a negative 25,000, and the probability is 1 in 200. So if you multiply all this out, what you're going to get is a cost of, it's going to be positive, so it's $175. So in the long run, if you look at a whole pool of people who buy this policy, the company, even after they pay out the claims, they expect to earn $175 per policy. Okay. All right, so if the company sells 25,000 policies, find the expected profit or loss. Okay, well that's just going to be the $175 per policy times 25,000 policies, which is going to give us $4,375,000. Okay, and that's the end of expected value.